Part 1 of this video will be about how to determine how many significant figures that a number has. Part 2 will be all about how to keep sig figs in mind whilst using mathematical functions. Significant figures are used primarily in chemistry to indicate how accurate a measurement is. In other words, sig figs are the number of digits that contribute to your answer. For example, 12 centimeters has 2 sig figs, while 45,687 meters has 5 sig figs. The more sig figs a number has, the more accurate it is. To determine how many sig figs a value has, the following rules are in place. Users are allotted one sig figure as a guess. All non-zero numbers are always significant. Any zero that lands before a natural number is insignificant. Any zero at the end of a number without a decimal point is insignificant. Any zero that is after both a natural number and a decimal point is significant. Any zero between two natural numbers is significant. Significant figures are not used in counting. Why are users given an extra sig fig for a guess?
Here I have a 1 liter bottle. It has no measurements on it because it's a very inaccurate measuring tool. But I do know that if there's no water in it, that it would be 0 liters, and that if it's filled up all the way, that would be 1 liter. Unfortunately, my water's filled up halfway, which is why scientists are allowed to use 1 extra sig fig as a guess. So I'm going to say that this is 0.5 liters. Now, I cannot say that it's like 0.57 liters as my guess, because that implies that I know that it's between 0.5 and 0.6, and I certainly don't know that. It could just as easily be between 0.4 and 0.5 liters, so I'm only allowed 1 extra sig fig to use as the guess, and that is 0.5, which would make a total of 1 sig fig.
All non-zero numbers are significant.
They simply all hold a place and make that number more specific for a measurement. The only important note is that I'll now be referring to non-zero numbers as natural numbers.
Why is it that any zero that lands before a natural number is insignificant?
Here I have my liter bottle with about 0.5 liters of water. So I'm going to write that on here. Now that's just 1 sig fig. The zero that becomes before the natural number is not significant. This is the only significant number. And this certainly doesn't change when I add another 0 at the beginning, because that makes no difference in what this measurement is. But this also applies to the zeros that come after a decimal place. This number, 0.0005, still only has 1 sig fig. To me, it seemed that since there was more decimal places, the measurement was more specific. But this isn't true, because this measurement is just what it is in kiloliters. And that doesn't make it any more specific. Just because I changed the units from 0.5 liters to kiloliters doesn't mean that this measurement's any more specific. For example, on here it says 0.05 liters. And that seems like it's more specific, but it's really not. It would be no different than if it just said 50 milliliters. Those zeros make no difference, since it's pretty much just a change of units that makes it have those more decimal places.
Any zero at the end of a number without a decimal point is insignificant.
We have our 0.5 liters, and if we want this to be milliliters, that'll become 500 milliliters. And while it's more places, this isn't any more accurate. All we did is change the units. I have measured out 500 milliliters, but that's no different than 0.5 liters, which it says right on the other side. So those both just have 1 sig fig. They're just as accurate as each other, even though they both have different numbers of placeholders. Those zeros just makes it the unit that it is, because measurements always have units.
Any zero that is after both a natural number and a decimal point is significant.
If I measure out 2 teaspoons of water in this little cup, this cup is labeled by 2 teaspoons, 3 teaspoons, 4 teaspoons, so it's in intervals of 1 teaspoon. And I can say that this is 2.0 teaspoons, and that 0 after the decimal point and after the 2 is significant because I'm saying that I know for sure that this number is between 2 and 3 teaspoons. And if this was even more accurate, I would be able to say it was 2.00 teaspoons. All 3 of those numbers would be significant, those 2 zeros, because I'm saying with the first 0 that I know that this number is between 2 and 3 teaspoons. And with the second 0, I'm saying I know that this number is between 2 and 2.1 teaspoons, because each 0 that comes after the decimal point indicates another level of certainty.
Any zero between two natural numbers is significant.
If I write 50.2, that zero is significant because it tells me the numbers between 50 and 51, since I have that 0.2 at the end, which acts as my guess. So that number would have 3 sig figs. Or even if I have a number that's 500.0, since that 0.0 is significant, as I just explained, we know that those 2 zeros that come before the decimal point are also significant because those are placeholders that come before the 0.0, which indicates my level of certainty. So that number would have 4 sig figs.
Significant figures are not used in counting.
So if I have this cat, this is not a measurement, this is a count. I have 1 cat, but that does not count as sig figs because counts are not measurements and those don't have significant figures because there's no level of accuracy. I'm pretty sure I don't have 1.2 cats or 0.8 cats. This is definitely just 1 cat.
Now for part 2, where I'll show you how to add two numbers with differing numbers of sig figs, or how to multiply, or how to subtract, or how to divide. Any mathematical function used in sig figs, even when you're using both in one equation. I want to find the total length of my cat. According to my dad, the cat is not significant, but I can assure you that the measurements are. I found the length of her body to be 18.56 inches. But when I measured her tail, she moved too fast before I could get a more accurate measurement, so I only found it to be 9 inches. So when I add these two measurements together to get her total body length, how will I know how many sig figs my answer should have? Before adding anything together, we have to make sure that everything is in the same unit, which my measurements already are. My measurement of Kitty's tail is not as accurate as my measurement of her body length. Unfortunately, my final answer can only be as accurate as my least accurate measurement. When adding or subtracting numbers, this is dependent on the number of decimal places your numbers have. So since my least accurate number, 9, has no decimal places, my final answer cannot have decimal places. So I'm forced to round off my final answer of 27.56 inches to be 28 inches. While this is frustrating, I have to do it because I'm implying that I know my final answer to be between 27.5 and 27.6, but I do not know this because my measurement of her tail, 9 inches, could be 9 1/4, and I'd have no idea because my measurement is not that accurate, and that would completely change my final answer. All I know for absolute certain is that the final answer is between 20 and 30, as is represented by my proper number of sig figs. In contrast to adding, multiplying is based on the total number of sig figs for each value. For example, to bring it back to my sample problem in part 1, if I multiply 0.5 liters by 1,000 to make it into milliliters, the number of sig figs would clearly need to stay the same because the measurement doesn't become any more accurate. This applies to any type of multiplication or division with sig figs. In addition and subtraction, we use the number of decimal places because the units will always be the same for each value. But in multiplication or division, units are often mixed, for example, finding the density. Since the units don't match, we must keep our final answer having the same number of sig figs as the number with the lowest number of sig figs. I want to find the density of my phone. I found the mass to be 4.80 ounces. Again, that 0 at the end is very important because it makes my measurement 10 times more accurate. And now I just need to find the volume. One way to do this is through length times width times height, but my phone isn't quite rectangular, so I'll find it through water displacement. My water started as 2.0 liters, and once I added my phone, it became 2.2 liters. I subtract 2.0 from 2.2 to get 0.2 liters. My sig figs are correct since all of my values have one decimal place. Density is equal to mass over volume, so I'm going to divide 4.80 ounces by 0.2 liters. The calculator gives me the answer of 24 ounces per liter, but now I must ensure that my sig fig count is correct. My ounces have 3 sig figs, but my liter only has 1 sig fig, so I must demote my final answer to its rightful place of 1 sig fig, becoming 20 ounces per liter. Before we leave the world of sig figs, one small note. If I want a number like 200 to have 3 sig figs, we can indicate that the zeros are significant by placing a line above it. That's all. Thanks for playing.